Okay, so where I want to go now is page 61 in my text. It says weighted averages at the top. And I want you to calculate this just using what you already know about the average. Find the mean of those scores. And then what we're going to do is we're going to use the weighted average process to show you how you would do that and that you get the same answer. And then we'll kind of go into some other areas here. So I'll give you a minute to do that. I'm going to get this information copied over here. Sorry, I had to get some water. Okay, what'd you get?
16.25.
Okay. So let's look at it through the weighted average lens and let's see if we get the same answer. So first step is to make a table, right? So what I would do is put number of students and then the score that they got. And that's essentially the structure for my table. So 5 students got a 10 and 5 students got a 15 and 10 students got a 20. So this is step 1, just make a table. All right. What's step 2?
Multiply across.
Okay, so we take this, use this. I use Excel to do my calculations. This is autofill here, it's pretty cool. All right, so that's step 2, multiply across. What happens next?
Add down.
Okay, so I'm gonna use sum, and I'm gonna add all 3 of these columns down. Okay, now this number here in the bottom right corner is important. It's essentially, it would be my answer if I'm done. And whether I'm done or not is contingent on the numbers that were provided to me in the table. So this is where step 4 comes in. Step 4 is the kind of the hardest one because it has an if statement. Divide if necessary. And the if necessary is if there are no percentages in the table. So are there any percentages in the table?
No.
No, that means we need to divide. Now, that brings up another point, which is, well, what do you mean divide? What am I dividing? I got a bunch of numbers I could divide. So that's kind of a hard question. There's 2 ways you can think about it. One is trying to think about what this term, average score, means. It's essentially kind of a score per student type of ratio. So that tells me that I want to take this 325 and divide it by the 20. 325 divided by 20. And that is going to give me my 16.25. The other way to think about it is by looking at the result, you can try dividing different things and you should get a reasonable average score once you're done. And what I mean by reasonable average score is, for instance, if you had thought to yourself, well, I'll take the 325 and I'll divide it by 45, this number 7.2, that doesn't make sense. The lowest score was 10 and the highest score was 20. There's no way that an average was 7. That's an important thing to keep in mind as we're talking about averages. The weighted average is still just the average. It's the mean. We're just doing it in a different way. Now, you might think to yourself, well, this is really a lot of overkill for doing something that I could do by hand. But there are lots of situations where actually there's no easy way to just add up all the numbers and divide. So let me give you an example of that. So I'm going to give you 2 academic examples. The first one ties directly to our class because we do a weighted average here for our class, which is every category has a weight and that weight impacts your grade differently. So 30% of your grade is different than 10% of your grade. In fact, 30% is 3 times as important. I'm going to give you a simplified version and say you have a class where there are 3 categories: quizzes, homework, and tests. Okay, and let's say quizzes are 20% and the homework is 30%. and the tests are 50%. So these are what we call the weights. And this is how the person did in each of those categories. Let's say they got an 80 on their quizzes, they got a 90 on their homework, but they only got a 60 on their tests. So how did they do in the class? Instinct was, I have no idea. That's good, because it's complicated. We got to calculate it to figure out what it is. On the other hand, probably no idea is a little bit less than accurate, because, again, using a standard grading scale here, a 90 and above is an A, and a 60 and below is an F. So, or 59 and below is an F. Given that their average has to be somewhere between 60 and 90, you can reasonably say there's only 3 grades that are really possible here. They could have gotten a B, they could have gotten a C, or they could have gotten a D. So no idea is not quite right, but I don't know how it's going to turn out, because, for instance, they got an A in one category that was worth 30%. But that's not the most important category. The one that was most important, they only got a D on, and it was a low D, right? So this is where we would want to use the weighted average situation. We can't just do 80 plus 90 plus 60 divided by 3, because that treats the 3 categories as equally important, and they're not. Now, as you're getting ready to, I hope you're copying this down or whatever in your notebook, as you're getting ready to multiply across, it brings up an important question about multiplying with percentages. What is 20% of 80 or 20% times 80? And I would not get into setting up proportions for each of these. I would just do the calculation directly. So what do I mean by do the calculation directly? Well, remember that percent means percent, which is divided by 100. And so what I do when I do 20% of 80 is just do 20 divided by 100 times 80. You could also do 20 times 80 divided by 100. It doesn't really matter the order that you do that in. But that's the number that you would get for here, and I'm going to call this the contribution column, because it's what each category contributes to their final grade. Okay, so go ahead and see if you can multiply across, add down. I'll give you a minute for that. Let me know if you're struggling. Need more time?
So I had a question.
Yeah.
Sorry. So is this okay to use instead of how you did it, like 20% times 80?
Uh-huh.
Instead of doing how we set it up as like a fraction almost?
Yep.
Okay.
You mean to set up the proportion?
Yes.
You can. I mean, the reason I'm trying to steer you away from that is because if you have like 3 of those to do, it just is kind of onerous. But the proportion would work as long as you put the 80, 90, and the 60 at the bottom of your part to whole ratio, then it'll come out right. So no problem there. If you multiplied correctly, should have got 16, 27, and 30. All right. And so what's the next step after you multiply across?
You add down.
Exactly. Okay. And so the sum of those 3 things is 73. So that tells us they got a C, which I guess makes sense since it's kind of in the middle. Not a bad, wouldn't have been a bad guess without doing any math. Okay. Now I just want to point out something about your own grades here. This is a screenshot I took of a student's grades from the grade book. Even though there's lots of categories here, there's categories that don't have any grades in them, and then there's categories that have 0% impact. So when you're thinking about how your Ivy Learn ends up with 61%, it basically is coming, you can think of it 2 ways, 98.75 and a 23.33%. And then this one is worth 10%, and this one's worth 10%. But since they're the only categories, that means that right now, this is essentially 50% of the grade, and this is essentially 50% of the grade. So it's like you got to rethink the weights when it's an incomplete calculation, and this was the performance. So then if we multiplied across, I think I actually better rewrite those as numbers. This is going to be 98.75, and this is going to be 23.33. So then I multiply across, and then I add down, and you'll see that the score here matches the score on the left, right? So this is where the 61.04 is coming from. In terms of your own grade, in terms of the Ivy Learn grade book, I mean, this is way better than it was 10 years ago because students, it was a black box. You couldn't look inside of it and know, you couldn't, like in the middle of the semester, you didn't know how you were doing. I mean, except from just looking at all the papers that you got handed back. So it's way better for transparency that students can look and see, oh, this is how I'm doing in this category and this is how I'm doing overall. It's not really that accurate given that these are roughly small parts of your grade. It's 20% total, and there's some really big things that are coming. It's even more complicated in our class because of the official and the alternate system. And so you want to kind of think about how that all works together. This is maybe just a piece of information that's like, hey, you know, you're doing okay, but there's some areas that you need to work harder. In addition, I want to point out that, like, for instance, this student has a 23% average, but they've got a score in their retakes. This does not automatically impact this grade. You have to actually change the grade. And this, again, one of the reasons why the first project is all about the grade book and making sure you have a working grade book for this class, because it is complicated with, 6 different categories. Okay, let's look at another academic setting example for weighted averages. So GPA is a figure that's used to communicate your average performance in a class. So we could look at different classes, how many credits they are, and the grade that you got. And we could turn that into the GPA using the weighted average process. So let's say you took math and chemistry and biology and English and Ivy, tech, college, prep, or whatever. I don't know what the name of the class is. Let's say math is 3 and chemistry is 4, biology is 4, and English is 3, and this is 1. And let's just make up some grades here. Let's say you got a C in math, and you got a B in chemistry, and you got a A in biology, but you got a D in English, and you got an A in Ivy Tech College Prep. Okay. Just some general things about grades for those of you who are new to the system or don't understand how things work. A D is credit. A D sometimes it's a complicated grade because sometimes it counts and sometimes it doesn't. For instance, if you get a D in this class, it counts for college credit at Ivy Tech. If you transfer, it may not count. If you're applying to the nursing program, they don't count it as a success. If you're doing human services, D is good enough. So, I mean, F is obviously failings, no credit, so you'd have to retake the class, but D is kind of in the middle area. A, B, and C obviously are success. So how do we turn this into a GPA? The thing that you need is the scale, the standard scale that people use, which is that a letter grade transforms into a number, and then from there we can complete our process. Okay, so what I would do is make a grade as a number. You can just write it next to the grade in your column. I'm just making a separate column for my own purposes here. You want to translate each of these letter grades into a number, and then you're off and running. You can multiply across, add down, and then you're on to step 4. Okay? I'm going to give you a little bit of time to work on that. So here's steps 1 and 2. Step 3 is to add down. Now, I've got a bunch of columns I could add down. So let's talk about picking it up from here. Is it possible that the final is the GPA is 41? Does that make sense? Do I need to do step 4? Is there a division step coming here, or am I done? That's the question.
I think there's more to do.
So we're in step 4, divide if there's no percentages in the problem. Are there any percentages in this problem?
No.
Yeah, then we have to go forward, right? So then the question is, what are we dividing by? The first part is we're taking 41 and we're dividing by something, but the question is, what are we dividing by? And again, I would encourage you to try to think of this as a ratio. This is the grade per credit. That's essentially what a GPA is. It's not the grade per class, it's a grade per credit hour. That's why credits are involved here. Because basically, this 1 credit class does not count as heavily as a 3 credit class. And a 3 credit class doesn't count as heavily as a 4 credit class. So that's the reason that credits get involved. So if it's grades per credit, then I need to take the sum of the credits, and that's going to be the thing I'm dividing by. So this would be equal to 41 divided by 15. So it's a 2.7 GPA, right? Don't get totally wrapped around the axle about your GPA. I mean, yes, it matters. It can matter in terms of scholarships. It can matter in terms of transfer and getting into certain programs, although I really like what they've done with the nursing program at Ivy Tech. There are different classes that count in terms of GPA, and there's other classes that don't. So for instance, 123, doesn't matter to them whether you get an A, B, or a C in the class. You need to get a C or higher, but once you've done that, that's what counts. You know, in the world, does it matter what your GPA is? Do people stop you on the street and ask you what your GPA was? No, it doesn't matter. Employers probably aren't going to ask you that. They just want to know whether you have a degree or not, and you have to provide proof that you got a degree. But you know, I don't know that your GPA really matters all that much if you got a degree. Okay, now I want to give you one last example. Any questions about the GPA question? Okay. So this is just one last example that's kind of another common type of problem. Let's say I've got a shop that sells things, sells shirts and hats and buttons, and I've got a price and then I've got the numbers sold. So let's say that shirts are $9 and hats are $7 and buttons are $1. Okay, so I could ask myself at the end of the day or the week or whatever, you know, what was the average price of something that was sold? So we're looking for the average price. This is a pretty common type of question for a test. The information is presented in a table. They ask for the average, but you have to realize because it's presented in a table, you should be thinking in terms of weighted averages, not just adding up 9, 7, and 1 and dividing by 3. That's the kind of trick that they're trying to trick you into. So go ahead and see if you can finish finding the average price. At the end, you're going to have to ask yourself whether you need to divide, and if you are dividing, you're going to have to figure out what to divide by. So some critical thinking there at the end to spend some time on. Don't say the answer out loud, just have a think about it. Of course, if you want to send me a picture, you can. Happy to look at your work. The other thing I like about this problem is that it kind of makes more sense in terms of what the numbers represent as you go through. So this number here is how much money was made total on each item. So you made $4,400 on shirts and $5,600 on hats and $340 on buttons. Then you do the sum after you multiply. And then what's the last step?
I would divide.
We're going to need to divide, correct? Because there's no percentages in this problem. And so then the question is, what do we divide by?
The price. And
So,
9, 7, and 1. You add them.
okay, so if you add these up,
Mm-hmm.
you get 17.
Mm-hmm.
And if you take this number and you divide it by 17, you end up with this number.
Mm-hmm.
Does this number make sense as an average price?
No.
Think about the lowest price is $1, the highest price is $9. So our average should be somewhere between 1 and 9. So you're right when you say it doesn't really make sense. But this is the hard part of the problem. Like, what do I divide by? The ratio is like the dollars per item. So it's this number not divided by 17, but divided by how many items you sold total. So if you take the 10,350 and you divide it by the 1630, that answer should make more sense. Because it's somewhere between 1 and 9, in the middle of 1 and 9. That's what we're doing. We're finding an average. Okay.